today's lecture we will solve example number 1.10. In this example, it is given that there are two charged particles at point A and at point B. The charge at point A is minus 10 microcoulomb and the charge at point B is plus 10 microcoulomb. Also, the distance between these two charges is given 5 mm, and we know that if there are two charges of same magnitude and opposite polarity, see, one is negative and the other is positive, then this system of charged particles is called an electric dipole, and the distance between the two charges is taken symbolically as twice of A. So this distance 5 mm is nothing but it is 2A. Given here, a point P is at a distance 15 cm from the center of a dipole. So from the center, this distance is 15 cm. Let us take this as R, and we know that this line which passes from the charges is called the axis of a dipole. So here we need to find the electric field at point P due to dipole. Now we have already obtained the formula for the electric field on the axis of a dipole. But here we can see that the distance twice of A is 5 mm, and therefore A is equal to 2.5 mm. Also, R is equal to 15 cm. So compared to this distance A, which is 2.5 mm, distance R is very large, which is in centimeter. So here the condition is that R is very greater than the distance A. So if this condition is there, so here we can use a simple formula for the electric field on the axis of a dipole, which is E is equal to 2 Kp by R cube, where P, which is an electric dipole moment, which is equal to 2A cube. So in our last lecture we have studied about the electric dipole. We have also obtained this formula. Now here the charge is given. Charge Q is 10. This charge Q is 10. Distance A is 2.5 mm. Distance R is 15 cm. So now we have to simply put the values, which is equal to 2, that is this value of K is 9 into 10 raised to 9 into P. But what is P? It is 2A. So it is 2A. How much? 2.5 mm. So 2.5, say this is millimeter. when we put the values, we have to put the values in SI system. So millimeter is there. If we convert that into meter, then we have to put 10 raised to minus 3. So 2.5 into 10 raised to minus 3 is nothing but is value of A in SI system into charge. Q is 10 microcoulomb. 10 micro. Now again microcoulomb is not SI system. So in place of micro we will put 10 raised to minus 6. So here we have kept all the values in the numerator part. Now in denominator there is R cube and value of R is 15 centimeter. So 15 into centimeter is there. So we convert in SI system. So 10 raised to minus 2 and its power is cube. Now after putting the values, you can easily calculate this using calculator and you will get this answer as approximately 2.6 into 10 raised to 5 and unit of electric field E is Newton per coulomb. So this is the value of electric field on the axis of a dipole. Now in next part we will find the electric field on the equator. Now again let us see this figure. Same figure which is given. Center of the dipole is O. Distance from A to B is given, that we have seen in the earlier section. And now the line which is perpendicular to this line joining AB is called an equator. And here a point Q is taken, which is at a distance again 15 centimeter from point O. So now here the distance R is equal to 15 centimeter, but it is on the equator. And now we are going to find the electric field at point Q. Again the condition is same. R is very greater than distance A. This distance A is very small compared to this distance, which is in centimeter. So using this condition we can use a simple formula for equator. E is equal to K P by R cube. Now to solve this example in a very easy method, we have seen that for an axis the formula for an electric field was 2 kp by r cube, but this is equator. So the formula will be simply kp by r cube. So simply we have to remove the 2 from that equation of axis. So here we can say that compared to electric field on the axis, electric field of equator is half. So we know that on axis the electric field obtained was 2.6 into 10 raised to 5, but this is half of that, so divide by 2 and you will get the answer 1.33 into 10 raised to 5 Newton per coulomb.
Electric dipole. Electric dipole is a pair of point charges with equal magnitude and opposite in sign separated by a distance. Many physical systems from molecules to TV antenna can be described as electric dipoles. A water molecule is an example of an electric dipole. Even though the water molecule as such is neutral, the chemical bonds within the molecule causes displacement of charges. This displacement of charges creates a dipole with a negative charge on the oxygen end and a net positive charge on the hydrogen end. If water molecules were not electric dipoles, water would have been a poor solvent. Subtopics: the field of an electric dipole. A. For points on axial line. B. For points on the equatorial line. The field of an electric dipole. Electric field produced by a dipole is known as dipole field. Let plus Q and minus Q be equal and opposite point charges separated by a small distance 2L. The strength of an electric dipole is measured by a vector quantity known as electric dipole moment P bar, which is the product of the charge and separation between the charges, that is, P bar is equal to Q into 2L. The direction of P bar is always from negative to positive. The SI unit of dipole movement is Coulomb meter. A. For points on the axial line. The axial line of a dipole is the line passing through the positive and negative charges of the electric dipole. Consider a system of charges minus Q and plus Q separated by a distance 2A. Let P be any point on an axis where the field intensity is to be determined. Electric field at P EB due to plus Q. EB is equal to 1 by 4 pi epsilon naught Q by BP whole square along BP is equal to 1 by 4 pi epsilon naught Q by R minus A whole square. Electric field at P due to minus Q of EA. EA is equal to 1 by 4 pi epsilon naught Q by AP square along PA is equal to 1 by 4 pi epsilon naught Q by R plus A whole square. Net field at P is given by EP is equal to EB minus EA is equal to 1 by 4 pi epsilon naught of Q by R minus A whole square minus Q by R plus A whole square. Simplifying, we get EP is equal to Q by 4 pi epsilon naught for AR by R square minus A square whole square. EP is equal to 2 Q by 4 pi epsilon naught 2 R by R square minus A square whole square. 2AQ is equal to P. K is equal to 1 by 4 pi epsilon naught, or EP is equal to 2 kpr by R square minus A square whole square along BP. A special case, if 2A much less than R, EP is equal to 2 kp by R cube along BP.